Alrighty, alright. We're going to talk about properties of logarithms. But before I jump into what the properties are again and show you some examples using them, I first just want to quickly talk about, well, first off, what is a log? Remember, a log is an exponent. It's an operation that allows us to solve for exponents whenever there's variables there. But all things considered, a log is an exponent. So before I jump into properties of logs, it's nice to think about the properties of exponents. So think back whenever we had like x to the third times x to the fifth. And when we tried to simplify that, and the reason why I'm trying to make the connection here, because remember, logs are exponents, so let's talk about properties of exponents. You'll find the properties of exponents and properties of logs very, very similar. So, and if I have x to the third times x to the fifth, what happened there was if I was multiplying two pieces, notice how I have a 3 there and a 5 there. Well, to condense, the shortcut there is we added the exponents. So the 3 and 5, we added them together, we got 8. So when you're multiplying there, you add the exponents. Well, guess what? The same thing happens with logs. If you have log of x times log of y, just how earlier we added the exponents, same thing here. We're going to have log of x plus log of y. So earlier we did log x to the third times x to the fifth, add the exponents, got 8. Same thing here. Another example, if we have log of x divided by y, let's talk about what happened when we had properties of exponents dividing. So if I had x to the seventh divided by x squared, the property of exponents, the shortcut there was take the exponents and subtract. So we took 7 minus 2, and we got 5. So when we're dividing, we subtracted the exponents. Well, guess what? When we're dividing over here with logs, log divided by x divided by y, how we subtracted exponents here? We're subtracting exponents here. So we're going to have log of x minus log of y. So you can kind of see a little bit of the pattern there. The last one is when we're dealing with properties of exponents, like say x to the fourth squared. Well, the trick there is when we had an exponent on the inside and an outside there, we multiplied there. It took 4 times 2 and said, well, it's x to the 8th. All those should be review for you at this point. So, but when we had two exponents there, an exponent raised to an exponent, we multiplied. 4 times 2 is 8. Same thing here. We have log of x, which that is an exponent right there, because remember, logs are exponent. An exponent raised to an exponent. When you have that, we're going to multiply. So we're going to have m times log of x. Multiply. So those are our properties. So quickly going through, I'm going to show you how to expand the following using properties of logs. So I have log of 3x to the 7th divided by y squared. So first thing I'm going to do is, since we have that division sign, reference our properties. So if we're dividing, we're going to go to subtraction. So this is the same as the log of this top, 3x to the 7th, minus, since the division sign says, hey, if you're dividing and subtraction, log of y squared. After I take care of division, typically I look at, well, is there any multiplication properties going on? So over here I have 3 times x to the 7th. Again, when you have two things multiplied, we separate them by addition. So we're going to have log of 3 plus, and now another log x to the 7th. Now this minus log y squared, we didn't do anything with it on my next step, but it's still there, log of y squared. Final thing I'm going to look at is I'm going to look at, do I have any of the properties of logs dealing with exponents? Remember, when we have an exponent like x raised to the m, you just bring the exponent down front, m times there. So this log of 3, nothing changes there. Still have a plus sign, but this 7 has to come down front. So we have 7 log of x. Over here, still have a subtraction sign. Log of y squared, this 2 has to come down front. So 2 log of y. So that would be expanding this out. My last example, I'm going to look at condensing. So I'm kind of going to do my steps backwards. You notice I did division property, multiplication property, then the exponents. I'm going to work exponents backwards. So I'm going to look through and see, do I have any exponents? So I'm looking for numbers in front of my log. So I have this 4 in front and a 9 in front. So natural log of 3, that's going to be left alone. But remember, when you have that number in front, that's the same as an exponent there. So if I have a 4 in front, that becomes natural log of x to the 4th. Still have this minus sign. I have that 9 in front. That's going to become natural log of y to the 9th. So I brought those exponents up. Next thing I'm going to do is, after I dealt with the exponents, I have those taken care of, I'm going to work with going left to right, putting these back together, because we are condensing here. So looking, I have a plus sign there. Now remember from earlier, when you have plus signs, that means multiply. So I have this 3 here and an x to a 4th. So I'm going to go from 2 logs to a single one, but it's 3 x to the 4th. Now I like taking things one step at a time, so since I dealt with these two using the addition and multiplication kind of going on there, I'm going to leave that minus natural log y to the 9th alone for now. Next, still going left to right, I have the subtraction sign. Remember, when we're dealing with subtraction, we're actually going to division. So I'm going to go from 2 logs, natural logs, down to 1. And remember, if you're subtracting, we talked about earlier that that is division. So on top, I'm going to have in my numerator 3x to the 4th. On bottom, y to the 9th. Now notice how in condensing I went from 3 logs all the way down to 1. And that is condensing logs, and that is properties of logarithms.